What is up, guys? My name is Cherno. Welcome back to another Cherno live stream. I don't think I've said that in about 6 months. How's everyone going? Oh, let me know the mix. Like, it's been so long, I don't know if the music's too loud. Like, you gotta let me know. Because hooking all of this up, like, took, you know, longer than it should have because of how long it's been. Sounds great. Okay, good. Good. Oh. Oh. I just need a minute. I just need a minute to just chill here. Okay, so the plan, I don't know how many of you watched the video that came out yesterday about Hazel like being free and our roadmap working towards that and all that. But basically, yeah, if you did, then you would probably know what we'll be working on today in this stream, and that is going to be like the new renderer. So this is a project. Actually, let me bring it up on the roadmap. So hazelengine.com/roadmap. Let's have a look, make sure all these layouts are set up nicely. So we got this like roadmap here, roadmap to release, right? And this is on hazelengine.com/roadmap, or you can just go to hazelengine.com and then there's this little Milano board button over here and you click it and you get taken there. So Renderer 2025 is basically what we're going to be working on. And there's like, you know, for those of you who do have access to Hazel, it's on the Renderer 2025 branch. So you can kind of follow along with this. I need to make sure I've actually done like commits though, because there is a branch called Renderer 2025, but you guys know me, I'm pretty like, I like to like not commit for a while and then suddenly, oh yeah, this is like rewrote the engine, you know, here's a commit. So I actually don't know if I've done any commits. That would be embarrassing actually, so let's cut that bit. But anyway, so Renderer 2025 on that branch. If you have a look at this card as well, which is also on the homepage of this board, then you can kind of see, I don't know why I'm zooming in with this, but you can kind of see like what this feature actually is, right? It's basically, it's something that has been in progress for quite a while. I think I started it like late last year. It's just I honestly haven't worked on Hazel that much lately. It's kind of been like something, if I've got a spare few hours, which happens like once or twice a month at this rate, that's when I kind of sit down and work on Hazel, which is why this has been taking so long. I don't think it's like, it's definitely not an easy task. It's quite an involved task, but it's not like an impossible task. But it's taken me this long just because of the amount of time I've been able to dedicate to it. You haven't committed. Thanks, Loxar. Where's the ban button? All right, anyway, so I will commit. Maybe I'll commit right now, actually. If people want me to, I can just commit work in progress, even though nothing compiles. In case anyone who does have access to Hazel might be interested in exploring like what I've done so far. But yeah, basically where like we used to be on like Renderer 2023, which is kind of that's the last time I rewrote the renderer, because this like rewriting the renderer happens like, you know, once every couple of years for sure. Thank you GT Lugo for the Prime sub, appreciate the support. So yeah, like ever since then, like we have basically decided that like we don't want to we don't want to be the ones to actually handle the implementation of backends. I'd rather outsource that to NVIDIA, because they have this library called NVRHI, which is pretty good. And it basically just abstracts away Vulkan, DirectX 11, and DirectX 12, as well as a whole bunch of other features. I am going to make a video specifically about this. I have talked about this before in Hazel devlogs, in the one about the new renderer, which is, I think it's called What's Happening with Hazel. It's the not yesterday's devlog, but the one before that. So yeah, like it does a whole bunch of additional stuff, but yeah, I will make a special video, like a dedicated video talking about, I think, this and how to set it up for like one of your projects outside of Hazel. But yeah, it is pretty cool. I haven't, the funny thing is I haven't officially used it yet, because usually what I like to do is I like to set up like a sandbox, you know, and then maybe test out stuff. But with this, I just kind of jumped in. I'm just kind of like, okay, this is exactly what I need. I obviously, like, I looked through the source code, but I didn't like write a standalone app that implements it, and you know, use that as like a test bed or like some kind of sandbox to make sure that I know how it works and that it works well. And I did explore their examples, obviously, but I didn't make one of my own or anything. And so because of that, like, I'm kind of learning this / using it, you know, implementing it just in Hazel straight away, and we're kind of seeing live, you know, how it's coming together. So it's kind of interesting. I think it's kind of interesting, but that's why I want to make that video as well, just because I want to have like an example of, you know, maybe it's something we could port Walnut to as well in the future, but it'd be nice to just have like an example, because I'm pretty sure the way that this is put together, like, there is no, I don't think there's an example. Like, the example for this is basically Donut. That's what I was talking about when I'm like, I looked at like the example projects. I looked at Donut, and that implements it, just because this is such a bare bones library in terms of like, you have to like, you know, BYO swap chain and like kind of set all that stuff up. You have to initialize the APIs on your own. It doesn't really do that. It's not supposed to do that. So that's why it requires quite a lot of additional code in order to actually see how this works. But there is a good programming guide and tutorial that you guys can check out. Anyway, so yeah, we're basically just going from, you know, moving this render backend abstraction to NVRHI, and then we can basically remove the Vulkan renderer from Hazel, because what's going to happen is, instead of like, so Hazel has its render API, so we'll say that's Hazel, right? This is the Hazel render API, Hazel Rappy. Well, it's almost kind of rapey, which is why I didn't really. Anyway, hopefully I don't get banned from Twitch. Sorry. Let's call it the API of rendering, the appear. Appear. The graphics will appear on the screen. That's much better. So we've got the API of rendering, and then from there we basically go to an implementation like Vulkan, right? And we used to, it's now gone, but we used to go to OpenGL as well, so we could kind of pick which one you want. So we got rid of this, and so now this is how it's set up. But what this is going to now do is the Hazel API of rendering is going to go to NVRHI. Half of this is lowercase, half of this is uppercase. Yeah, I'm a bit rusty with my streaming. But anyway, so we've got the Hazel API of rendering going to NVRHI, and then that obviously branches off into the three things, being like, you know, D3D 11, 12, and Vulkan, right? And then in the future, we could add something like, say, Metal, or like, you know, GNM, GNX, whatever, Sony APIs, like whatever we want in the future, we can kind of introduce that stuff at this level, right? So because we don't have Hazel's API now directly uses NVRHI, we can, yeah, remove that like Vulkan section. So anyway, and then, yeah, there's some stuff that I've written down here, like, and this is like, I'm going through this, by the way, not just for you guys, but also for me, because I haven't obviously worked on this for like, well, over a month, definitely. So I need to refamiliarize myself with where I'm at and what my thought process was, which is, by the way, like this Milano board, which is on hazelengine.com/roadmap. This is kind of, this is a good kind of documentational note-taking point for me as well. So if you guys are interested in how stuff is going, then I would say kind of keep an eye on this board. I don't know if you can like subscribe to it. That would be nice, so you can see changes. But anyway, whatever. At this rate, so let's see what I had written down here. So we've got the NVRHI support with Vulkan and D3, D12. Yeah, so I would like to get the DirectX layer working as well, just because that would be obviously a good test for this now supporting DirectX 12 as well. But we're gonna start with Vulkan just because Hazel obviously runs with Vulkan, and also in order to support D3, D12, we're gonna have to set up this like shader cross compilation, because at the moment we just support SPUR-V shaders, which are for Vulkan, and DXIL and DXBC are needed for DirectX 12 and 11. Sorry, DirectX, yeah, 12 and 11 respectively. But also this automatic resource tracking and state changes I really want to explore, because I think that's going to just make Hazel's renderer rock solid, heart touching, you know. And then think about shader pipeline and possibly drop support for GLSL to reduce pipeline complexity we'll see what happens with this guy, just because I don't want to drop support for GLSL. Still think that's kind of my preferred shading language, but the truth of the matter is if we just switch to HLSL for Hazel, then we can just go from HLSL into any bytecode format. So from HLSL, you can go directly to DXIL, DXBC, and SPIR-V. Whereas with GLSL, you have to first go to like probably to SPIR-V, and then from SPIR-V to HLSL, and then from HLSL to DXIL or DXBC. So there's like, it's harder to get it to work across all APIs, which is why, game engines tend to either have their own shading language or use something like HLSL, or there's like other, I forgot what it's called. There's like some other intermediate shading language that people use as well. Will Hazel support the PlayStation? Well, not at the moment. We don't have any plans for that at the moment, but in the future maybe. I think I would like to probably support the Nintendo Switch, although I don't think I love Nintendo as a company. But I like the Switch, and I have a Switch. I'm probably not going to get a Switch 2 for a while though, because they're kind of expensive and the games are expensive, and I don't actually play games that much, but I just like the idea of having like a handheld kind of console that you can also obviously dock, connect to your TV. So I do like the Switch, but and then that can use Vulkan. They have their own API, Nintendo, but I think they also support Vulkan. So it's kind of like, you can have Vulkan be used on like Mac OS, but it's not native. It's kind of the same thing. Reaction to GTA 6 trailer 2. Yeah, I was going to, I already watched it, but I was going to make a reaction to it, but I think what I'm going to do is I'm going to wait until an actual gameplay trailer drops, and then I'm going to do probably a reaction. I'll record it and post it on the main channel. So that's my plan for GTA 6. Because yeah, like it does look pretty cool, and it's just, I don't know if it's worth me saying anything almost about the actual trailer so far, because they're like cinematic trailers, and so who knows what they're doing. That could be baked, that could be there's a million things that happens there. But if it's an actual real-time gameplay trailer, I'd probably be more interested in taking a look at that. What program do you use to write it on your screen again? Zoom it. I should get like it's a free app, but I should get some like commission. I should get some like affiliate link going for that, because people ask me that every stream and probably every video. Okay, right. So, yeah, let's actually get on with some programming, I reckon. So, yeah, just one final time, hazelengine.com/roadmap. You'll find this page here if you go to, well, it's either here, Render 2025, or Roadmap to Release, and then you can see the big picture. So this is something that I've wanted to get up for you guys for a while, just so you can see, like, this is Hazel, this is what we're doing, right? And then this is the big goal of like, okay, we can release it now, like for free, binary release for free, and people can start using it. And it's not even just the fact that it's now free to use, and like you can make games and ship them and do whatever you want with it for free. It's also, it also signifies obviously like an achievement in terms of like, okay, this is almost like Hazel 1.0. This is like Hazel is now like, I am now comfortable being like, guys, you can make games with it. Would I make the next like big budget AAA, like a lot of investment game in it? No, it's still a very young engine, and it's definitely not like we can't offer the same level of support that maybe another engine could, but it's definitely like okay to play around with and try and make some stuff in and see how you go. That's kind of where we're at. All right, awesome. So Visual Studio, my old friend. I have not done any programming in so long. I obviously there's the code review series, and I think I have done some programming, because recently I made that video about like using the GPU to, go from like 33 frames per second to like 7,500 or something, right? That was the pseudo 3D rendering kind of code review, but then I took it from CPU to GPU. So that obviously I did the programming for, but I haven't actually like sat down and been like, okay, work session in Hazel for a while. So maybe you can see the smile on my face. That's pretty genuine, because I'm kind of excited to do some programming. This smile, by the way, is probably going to go real quick once we actually get into this, because this is not the most funnest of tasks, obviously. It's not very creative. It's just like porting, basically. All right, let's do a little compile. Now, this does not compile. I'm just gonna say that immediately. This does not compile, but I just wanna see like where I'm at. Oh, and I have a I had this like last time I streamed as well, but I have officially a dedicated stream PC. So look at this. I'm still in, what am I streaming at? 25 FPS? I'm still in 25 FPS and not dropping frames, even though I'm compiling on all cores. So isn't that cool? Yeah. All right, so we've got like a sweet amount of errors here. Like 1658 is good. We want to aim for less than 2000. I don't know what I'm saying. Actually, a lot of them seem to be GLSL errors, which is stupid because I don't even know why we're compiling that. So let's maybe start by disabling. So this is how you work your way through the error list, guys. You start disabling like features that lead to errors. So like, for example, we don't need to compile this GLSL code using this extension that I'm using, right? So let's just disable that and we'll immediately reduce our errors. You know what I'm saying? Yeah. All right, so GLSL, so see this like live compiling. GLSL language integration, by the way, good little extension for Visual Studio. Live compiling set to true. We're gonna turn that sucker off, and then hopefully we're gonna be setting at less errors. We might even have to restart to clear that error list or whatever, because I don't think that extension nukes it. Good morning. On schedule Twitch part, there is only the Monday. Any planning to update schedule? Oh yeah. So I'm probably gonna do, we're still on 1658. Yeah, see, it hasn't cleared it. So let's restart Visual Studio. We're already restarting Visual Studio, guys. This is a genuine programming session. Like, this is real. This is as real as it gets. Yeah, I'll be doing a stream, I think Wednesday morning. So I said in that video yesterday that I posted that I'm gonna be doing like one stream at this time per week, and then one stream about 9 hours earlier than now, right? So see, 15, is that? Yeah, 15:05. We're already getting somewhere, you know, we're reducing those errors. So yeah, I will quickly, you know what, I'll do that right now for you. I'm gonna go to the schedule, if I'm logged in here, which I hopefully am. And I'm just gonna add in that stream roughly at what time it's gonna start. And then yeah, I'll probably make this a recurring thing, because this should happen same time next week as well. So let's do, I'll just write, I won't write a title for it, but we're obviously going to be doing that. So let's do like, yeah, every Wednesday at, when should I start? At 10 a.m. my time, 9 a.m. 9's probably kind of early. Let's just do 10. Maybe I'll end up starting it earlier. Depends. I usually end up getting up pretty early because of the kids. But yeah, okay, so that's now in the schedule. So you can see my next stream, and then I think this, yeah, I'll update. It'll be same time next Monday as well, next week, but I'll update that later because I can't at the moment because it's in progress. All right. I recently switched to JetBrains C-Line/Rider. There will be no coming back for me. Yeah, I still think I prefer Visual Studio for C++, and I guess C#, but I don't know, like, I do like C-Line though. I used it, because I did a sponsored video with JetBrains. I used it to rewrite like my first game in C++, the Genesis game, obviously. That's the only game I, you know, rewrite a million times. But, yeah, and it was fine, it was good. But like, I don't know, for something like Hazel, I still kind of, I think I want Visual Studio for something like Hazel, for something of this scale, you know? And also, you know, mixed C#, C++, I think Visual Studio does pretty well. And with Visual Assist, it works, it does everything I need. And I don't know, maybe I feel more comfortable because obviously this is what I use, like Visual Studio plus Visual Assist is what I used at EA to work on Osiris, Mobile Engine, and then later Frostbite. So because I've been at that scale in Visual Studio, in this current tool set, I know I can handle it. And I just feel, I don't know, I just feel more comfortable, I guess, because obviously this is where I spend most of my time. So not debating that it's better, I'm just saying for me it's better, that's all. And also, like, again, I say this a lot, but I do not really care what tools you use. It's more about like the results than like, you know, if you get too hung up on the tools, like start like switching between them, trying to figure out like, oh, is this better or is that better? Like, don't get too into that, because then it's almost like, you know how people say like gear doesn't matter? Like it does to an extent, but like you don't want to get too hung up on that. Like start making stuff. That's better. All right. Right, so where do we begin, is the question. We've got a lot of errors here. I don't know why we have so many in index buffer, because that should be basically finished. Missing type specifier, int assumed. Okay, so buffer isn't included probably. Well, let's try and include buffer. NVRHI is not a namespace. So what's the include for that? Did I already do it for vertex buffer? Yeah, so it's just this. Include order, I like to do Hazel stuff first, then non-Hazel modules, but that are in here, source available, and then library things. And I do like external stuff, I like to do with Angular brackets, just to kind of be like, hey, the code for this is here in this solution and in this like project, we'll say. Like by project, I don't mean Visual Studio project, I mean like Hazel. It's in Hazel, right? Whereas this is like, this is an external module that I don't have the source code for. So that's usually not, there are exceptions, but that's usually how I differentiate. That's both include order. This would make a nice YouTube short, but that's both how I kind of go from, you know, how I add some meaning to both, like, well, determine the include order and then add some meaning to, you know, quotes versus Angular brackets, because there's no real difference. Like with quotes specifically, you could write this in quotes as well. You can't go the other way though, because Angular brackets have to be in compiler include directories, but quotes will first try relative parts, and then if that doesn't work, compiler include directories. So there you go, right? What's next? So yeah, well, let's keep trying to compile this one file. So you can kind of see my approach here, hopefully, if you're watching this to learn. I'm just kind of, you know, I went to the error list. I saw that like huge 1500 errors. How you even deal with that? Like, okay, well, let's just go find the first one or whatever in a place that I know I'm kind of working on. And then if you go to the CPP file, Control F7 just to compile that one file. And then that obviously reduces us now to 8 errors, and it's a lot more manageable, and we can kind of go through that. Okay, so VK clear value undeclared identifier. Okay, so we obviously, so that's actually from framebuffer.h. So that's, why is index buffer including frame buffer? Is it because it's in, no. What? Oh, wait, is it here? Oh, because it includes renderer, and renderer must include frame buffer. Why does it, oh, it has to include renderer. I don't think it has to include renderer anymore. I think it used to do that because it used to use the renderer submit function to submit stuff to the render thread, but we're not actually doing that at the moment. So I think we can get rid of renderer. Oh, okay, we can't because it needs, oh, well, we need application get graphics device. Did I want to go through application for that? I'm not sure, but anyway, let's do Hazel core application. And then now we got index buffer cannot access private member. Thanks for that. Yeah, so I've made the constructors private, and then I'm basically, you have to go through this static create function. The only reason I kind of did that was because, I think the code looks nicer. There's no real reason to add that in direction or anything. Obviously it'll like compile into being inlined and everything will be fine, but, so there's not gonna be any like runtime difference, but the reason why is because if you don't have that, so if we go to like edit a layer or somewhere, where can I write some code? On update. I don't know why that function specifically, but let's just write some code here. So if I do like, if I wanna create an index buffer, you kind of have to remember that the syntax is gonna be ref index buffer. Like you have to do ref index buffer. Oh, wait, how would you create a new ref? Oh, and then you probably have to do, I think it's also because we used to do hz new, is that it? Or is it h new, sorry. H new ref index buffer, and then you put your stuff in there. Whereas this lets you do index buffer create. The real reason, sorry, I should expand on this. The real reason why it could not have been this before is because index buffer used to be a base class, and then it would have several implementations such as like Vulkan index buffer in Vulkan or OpenGL index buffer for OpenGL. So there's obviously, you have to have something like this, then choose what to create with it. But now that we've moved that abstraction down a layer into NVRHI, we can actually have this code if we wanted to, but then, you know, you have to remember hnew for the tracking, and then, you know, it's just easier to do, I think, index buffer create and not worry about like wrapping it in ref, like, because then, like, what if people don't know how to do that? And they're like, oh, do I create a new index buffer like that? It's like, well, yes, I guess it'll still be like cast into a, it'll still make a, I think if you did this, as long as you use the right type here, I think that would actually work, because this would obviously call the constructor of ref with an index buffer pointer. Even though like the correct way to do this, oh, no, wait. I think it's this actually. See, I don't remember this. I think this is the correct way to do it, because yeah, that's why. It's been a while, sorry. Because you want to create a new ref, and you don't want to create a new heap ref. So that's actually, this is wrong, because you don't want to create a new ref on the heap, like with new. You want to have a stack kind of ref, but you want to create the index buffer from the heap. So what you do is you call, the ref class has a create function that you can see will do this. Probably should use hnew, but anyway, should probably change that. We'll do memory tracking stuff later, I think. But anyway, so because you do this, you want to call this create function. You just have to remember that you have to do ref of index buffer, then colon create. Which is just a bit confusing, and I think it's probably easier for most people to just be like, you know, I don't care about the fact that it needs to be a ref or whatever, I just want to call index buffer create, and that will work. This just needs arguments, that's why it's wrong. So, you know that. And yeah, so that's kind of why we went with this, but otherwise now there's functionally no reason to. Before, there used to be a reason to, because you'd have to specify specifically which one to create, and if you wanted to make the choice for you, you'd have to go through this function anyway, if you didn't know what render API you were using. Does the state of the drive instability on NVIDIA side might affect your tests, especially that NVRHI? Okay, that's a bunch of words. Yeah, I've heard something about NVIDIA drivers lately being a bit unstable, which is, you know, historically didn't used to be the case. So I don't know, but no, NVRHI has nothing to do with any of it. Like, NVRHI doesn't really have anything to do with NVIDIA. Like, it's written by NVIDIA, but it just utilizes Vulkan, DirectX 11 and DirectX 12, right? There's nothing really to do with NVIDIA specifically in that code base. It's just an abstraction for all that stuff. Like, you know, you can look at NVRHI and it's like, okay, this is NVRHI.h. It's just C++ code that obviously is going to implement either DirectX 11, 12, or Vulkan code. And then if you go to like something here, for example, you can look at like Vulkan graphics. And then if you look at this, like this is just, you know, Vulkan code. So it's not like it will only work on NVIDIA or it has anything to do with the driver instability. Like, you know, maybe you could say that, like, what does it say about the competence of the NVIDIA team? But the people who write the drivers, let me assure you, are not the people who write stuff like NVRHI. So anyway, I don't know. I don't know how stable this will be, but like, you know, if the drivers aren't stable, then what on earth can I do, you know? I can, yeah, so I don't think it's gonna matter. And obviously this is completely open source. I have all the code here. So if I notice bugs or things that need fixing, I'll fix them. It's still better than me writing effectively the same thing myself from scratch. You know what I'm saying? Not to mention the community will also, because it's an open source repository, like the community will also contribute back if they start using it, which is good. NVRHI is technically using Vulkan 1.2. That's not true, as far as I'm aware. I actually haven't updated NVRHI for a while, but I'm pretty sure it's Vulkan 1.3. Let's see if I can find anything here. Well, I mean, I'm using Vulkan 1.3 in here, and I think if we go to, I think at the moment it's been created an application, right? Where are we doing this? Window specification, window create. Where are we doing it here? Or is it happening in window? Oh, it's happening in window. Because we were running through this. Anyway, I'm pretty sure it's Vulkan 1.3. Like, I'm 90% sure. It says 1.2 on the top. Oh, okay, well, I mean, we could trace this. But anyway, it doesn't really matter. Because if I need a 1.3 feature, I just add it. You know what I mean? Like, it's not really an issue. Because, like, I don't know what you... Yeah, I guess it depends what you think this API is doing for you. But all it's doing is just abstracting away certain things, you know. So I can obviously, like, play with the implementation or add a function if I need to. That's not a problem. But I am curious, though. So if we have a look at Vulkan, create VK, device manager VK. Where's the constructor? This is a CPP file? Yeah, it is. If we go to the destructor, it's not here. Great. Create VK. Wait, so that, yeah, that does. So where's the constructor? Or create instance maybe. That does GLFW stuff. Well, I mean, here it's asserting for Vulkan 1.3 features. And in fact, it's actually enabling Vulkan 1.3 features. So there's your answer. But if we wanted to see what instance of Vulkan it's actually creating. Can I find create instance? This is just using, like, I think it's using Vulkan HPP, which I'm not as familiar with. That's like why I don't know exactly what to search for. So minimum Vulkan version. Well, yeah, look, VK make API version 1.3. So, and I haven't tweaked this. So yeah, maybe they haven't updated their README. But the reason why I was confident about that as well is just because I think I've seen some 1.3 features in the API. So therefore, yeah. All right. Anyway, that was a bit of a detour. So yeah, so index buffer, is this compiling it? Oh yeah, right. So, wait, but what can't access that? What's trying to access that constructor? Oh. Is that? That's annoying, isn't it? Yeah, because I guess that didn't used to happen. But that did used to happen. Like, that would have had to have... Let me just see. What else haven't we ported yet? Uniform buffer set, probably. Yeah, so that used to do ref fucking uniform buffer set create and... But that's public. Right. We just end up having that public anyway. So the issue at the moment is basically the fact that we've made the index buffer constructor private because we don't want people calling that directly. I mean, I guess we could let them call it directly. Why does it matter? People could use either the create function or they could create it directly if they want. Maybe that's probably the easiest solution. But anyway, so what we're doing is we're like seemingly like the fact that it's private would be no issue if we just called new from here. But because we're actually doing ref index buffer create, then it's actually kind of delegating that creation to the ref class. And the problem is the ref class doesn't have access to obviously the ref of index buffer class, because that's technically the class type, ref index buffer, that doesn't have access to the private members of index buffer. So it can't call these constructors. So we could fix that one of two ways. I think we could probably, like, technically speaking, as I just demonstrated earlier, we don't really need to get ref create to do it, even though it would be nice. We could basically do it ourselves by just doing return, you know, new, effectively this. I'd write it a bit differently, but effectively we could just do this and pass in buffer, right? So we could do that. That would work fine. Or I reckon I'm just not going to make this private. I'll keep these as public. I might still keep them divided here just to, if someone looks at this, they're like, okay, you're supposed to use these. But you can use these. Like, there's nothing really against using that. The reason why I just wanted to encourage more people to use this, but maybe there would be a scenario in which you, like, I don't know. What if you wanted to do like a placement new or something and you couldn't really without accessing the constructor? I don't know. But that should make those errors go away. Yeah. Let's quickly fix up this warning as well. So we're returning, I'll get count, return M size divided by 4, and then we can cast that to a UN32T because the count is not going to be above, you know, 4 billion indices. Okay, cool. So that should be good. Yeah, and anyway, so this is basically the task, guys. It's just gonna be this. Now, I'm not releasing anything in index buffer at the moment, so we probably want to do that. I've kind of forgotten exactly how we should be freeing this. Actually, do we need to do anything in here? Because buffer handle, but that's not an owning object, right? So what? I think we need to probably wait, or is it? Oh, it's a ref counter pointer, yeah. It's not, I thought it was like a UN64T, but no, this is an actual strong reference to it. It's a reference counted object. So if this gets released, then the index buffer gets released. And index buffer itself is ref counted as well, using Hazel's reference counting system. So I actually think we probably don't need to do anything in the destructor. So let's just get rid of the destructor. Or we could keep it, but have it be empty in case. Yeah. They're probably not strictly necessary, but yeah. What is ref counted, like a custom shared pointer? Yeah, basically. It's just an intrusive reference counting system instead of a kind of an external one like shared pointer. You can kind of achieve the same thing, I think, with shared pointers if you subclass a type that they provide, but this is just a bit cleaner and easier. Yeah, basically it just means it's intrusive in the sense that the reference count is actually stored with the object. So if you look at ref counted, it has that actual UN32T. And that just means that part of the object's composition is right there in the memory. It'll have that reference count. And because it's inside the actual object, it means you can do stuff like, I can do stuff like this. I can do ref index buffer, you know, instance equals this, which you cannot do with a shared pointer, with a normal shared pointer, because the reference count is external to it. So you can't just make it out of the current object that you're in. And this is important if you want to like submit some work that includes this instance to the render thread, and you need to make a new like reference counted object out of yourself. Equals default for compile optimization. Yeah, let's do that instead. That's a good call. All right. Yeah, so there we go. I guess we could even put this down here. So we have our public section with constructors and destructors. And then this is just like the creation stuff. And then we have the API. We'll keep that. Okay, so let's look at vertex buffer. I think we've already done that as well. So this is where it's got some stuff here that we should probably put elsewhere. This gets a bit messy, I think, but I think I've already done this class as well. So we'll probably have to make these public. We'll have that destructor, which probably does nothing as well. We'll move that here, make it default. We will, yeah, everything else looks good. Let's try and compile this. Okay, we got a bunch of stuff here. So missing type specifier. So same thing with buffer. Buffer not being present. Then we got, yeah, frame buffer, because this has renderer, which probably doesn't need, but it will need application. This is a very similar class to what we had before, hence why it's like the same. Did that compile? Oh, it did. Cool. Okay, so frame buffer is probably one of the hardest classes I would say to rewrite, just because this class does so much stuff. Like, but the thing is, I think have I already done it? I think I've partially done it. I don't think I finished it. I mean, there are errors everywhere, so I assume I haven't finished it. Yeah, and it does a lot of VK Vulkan stuff, which obviously it should have none of. So I think frame buffer is a class that I have not even touched yet. So let's leave it for later. So compute pass needs to be done. Debug renderer probably doesn't use. That just uses Hazel's API. Device manager is the NVIDIA, part of NVRHI, kind of. Image, have I done much of? Not really. I think Vulkan image 2D I started. Yeah, so this I think I did. Yeah, that's why it's got this if old stuff. Because now it just does this. And you can see it's using NVRHI. So this I've done to some extent, which is kind of nice. It looks like I've done most of this actually. I mean, this stuff shouldn't exist, I think. Copy to host buffer. Hazel's, there's quite a lot of stuff to do, guys. Material. Okay, so material, this is like a render side, like a renderer side material. So it's got implementation. So this needs to also use VK descriptor sets and stuff. Material asset, I think, is just an asset, so that should be fine. Mesh also is generic, as in it's not API specific. Pipeline is API specific. Pipeline I've done though. So if we look at pipeline, I think, yeah, so it's got this if old section that's done, and all of this is API. This is now NVRHI. So because this is done, one thing we should do is we should obviously move it up to the base class, right? So we basically need to grab, let's do this. Let's kind of put these side by side. I'll make it full screen, and then we'll get rid of this and this from here. And then, is there anything here that's specific? So shader, no, there's, oh well, yeah, use dynamic line width for some reason. And that's it, right? Probably. So yeah, so this doesn't have to be virtual anymore. These will all be implemented in here. We'll move that static create function up here. We'll have to have a constructor for it here. So the create function, we kind of got rid of, oh, right, I'll just have it here. So this will be return ref pipeline create. My C key keeps triggering twice, which is annoying. Okay, so if you see me type the same letter twice, it's not me, it's the keyboard. Blame the keyboard. Okay, and then, yeah, from here, I want to take, like, everything. So, literally, give me the pipeline, please. I guess we can do a cut. And then, yeah, so we're just gonna change this stuff. There is still this like VK format stuff, but I don't think we need any of it. I just haven't removed it. Cause yeah, see, we kind of rewrote like this NVRHI stuff here instead. Yeah, we don't need the destructor at all, I think. Specification we used to have. So this can be private. RT invalidate. Why does that? Oh, because at the moment we have to get this stuff. That's a bit annoying. Let's we'll keep Vulkan in here a bit just because I want to not have compile errors. I think this is in platform Vulkan. Frame buffer. Yeah, so that's fine. And then, I don't know, yeah, this should just be this, I think. I don't know why this gets its own function, but sure. And then this we can just remove. Yeah, and then here we have a lovely NVRHI style pipeline, which I think reduced it quite a bit. There's only 270 or so lines here. That's including all this actually. So, because this used to be quite long, quite verbose, quite long. All right, so now, so yeah, so we can get rid of, I don't think we use like get Vulkan topology. That's unused. Vulkan, we can't use any of this stuff. We can't be using any of this stuff at the moment. So I can get rid of it. And then what's the matter with you? I think I might be missing one of these. Yeah, and that's it. So now we can actually go here and delete Vulkan pipeline. So the idea is, guys, just to give you an idea of the scope, platform Vulkan like is basically getting deleted. There might be like some maybe device specific or whatever things that I keep in there, but basically what you're seeing here, like all of this is basically getting deleted. And we are, yeah, not using it anymore. So there's quite a lot of work to get done. I mean, yeah, like vertex buffers are done, I think. So I'm kind of leaving this stuff here. I probably shouldn't be, but this is done. Like, I just need to make sure that it's properly implemented before I delete it. And it looks like it is. So let's just delete it. I mean, obviously, like, you know, Git and other branches and whatever else. So it's not like I'm permanently deleting this from my life. And then where's index buffer? Because we did that as well. But it's nice to delete some stuff. Hazel 2D is dead, right? Yeah, I mean, basically, like, I don't know. I would like to revive it at some point in my life. But I just don't have time, like with, you know, 2 young kids at the moment and not even having time to work on Big Hazel and stuff like this. Like, it's just I'm not at a time in my life where I can probably invest in that. So yeah, but I don't know, maybe one day. But I don't see that. I don't know if there's any point. The other big reason that I didn't really, like, apart from the fact that it just didn't have that big of an audience, it's just obviously because it's been going on since when? 2018, that game engine series thing. Like, the people who were actually following along with it, unless someone new discovers it, and I guess catches up, you know, those people are like gone. Like, they're, you know, you don't follow a series like that for 6 years and actually, like, it's just too stretched out, I guess, you know? So maybe I would start another game engine series sometime in my life, but like when I have, maybe when the kids are older or when I'm like at retirement age or something, I don't know. But yeah, it just wasn't like, I don't even know what the audience is, what kind of people watch that apart from just like for fun, you know? So it makes more sense to probably not do that and to focus on other things that are more helpful to more people and will thus be more successful. Remember the hype before you started the game industry? Yeah, I do. It was, you know, the good old days. Okay, anyway. What should we move on to? So like, yeah, so image, we basically ported, I think, right? There's a lot of ifs and questions and stuff, but it's kind of ported. I don't know why this stuff is all upset though. Oh, well, this is a release, so this has to be different anyway. I think we might not have this stuff anymore, Vulkan image info. Oh no, we do. Well, we shouldn't. Alright, so I didn't get rid of this, but this is basically what it is. Image handle is image view is image view, and so we can probably get rid of this, just call this image info. We have a Vulkan image view here as well, which is an image view, so we can drag that up a layer maybe. Oh, that's right. But the thing is, these image views were a little bit, I kind of forgot. I don't remember exactly what they translate to in NVRHI. I think they're... So iTexture... I don't really remember. Might have to look at this. Probably not too important right now, but I think they asked something to do with texture. Texture slice? I mean, effectively, it's a texture slice, I think. Oh, texture sub resource set. I think that's what it is, and I think I've already done stuff with it. Yeah, so Vulkan image, you can see. RT create per layer image views, for example, uses texture sub resource set. So I've already done that. Texture sub resource set. Gotta remember that. Yeah, anyway, I want to start removing this stuff, basically. When am I going to finish this, I wonder? Update descriptor basically doesn't need to exist. I might I think I want to be a bit more liberal with my deleting of stuff, and then if it just doesn't, because I don't think I should be going like this. This is not a one-to-one translation, you know. It's not like a one-to-one porting thing. I'm trying to actually like, this is a new renderer, you know, so I have to actually reimagine stuff and rewrite some stuff, probably. I shouldn't just be trying to translate this directly, because I'm trying to make it better as well. Why did I leave EA? I made a video about it. It's like a 20-minute story or whatever, so go find that on my channel, and then you'll see. Image for image is, yeah, that's VK stuff. Copy to host buffer. So this is obviously something that we need to implement. Let's do that or something, because it's not implemented, just in case. And I'll keep that for now. We'll translate that later. I think we only need that for like packaging, asset packing, that kind of stuff. Yeah, Vulkan image view stuff. So this basically is going to become that like texture sub resource set thing that we talked about. Let's get rid of this. Yeah, we'll keep release for now, because I think that needs to manually be triggered, but that's basically just needs to release the reference candidate object at this point, I think. If investigate, nice. Oh, because this is if we want to defer the validation to the the creation of everything to the render thread, but I don't think we do. We just do it on the calling thread at the moment. Yeah, Vulkan image view. I guess let's let's do that. Because, yeah, we want an actual image view. So this basically... So public image view. Yeah, I guess let's just write it here. So... Because that Vulkan image view is going to go away entirely. So let me, let me go to Vulkan image.h probably, which is what we had up. And I'm just going to copy this stuff. Get image view is going to be the thing. And then it's got a specification. It'll have a constructor. And it's got, yeah, this stuff, which I don't care about. It'll be a handle. So this will be like NVRHI. Actually, it might not even be a handle. What is it? A texture sub-resource set. So that's an actual struct of data. So I think it internally caches it probably into an image view object or something. I don't know. So we might want to do a const reference because we don't want to copy that needlessly, I would say. I don't know what else to call it. Okay. I think get image view is probably not the best. Might not want to call it that. And get descriptor info. Well, yeah, we wouldn't. I think we would just do that with it. I don't think it really needs anything else. So we set a specification, then we make it by invalidating it. So let's maybe create those methods. And then we can kind of, yeah, so this is gone. Now we can kind of copy what we had in Vulkan image here. So obviously this just does submits to the render thread. So that, I don't think I'm gonna do that. I think I'm just gonna, yeah, there's no need for the render thread to probably take on that work. So we'll keep it as that. And then this obviously, I think just based on the specification, it's just gonna create this. So we're already doing this somewhere up here, I think. So this is really all it has to do. It just needs to, like it's just this, and then it's just gonna go through and what's in that specification? Just the MIP level. Not even like layers or anything. There is an image though. I guess it almost doesn't need that. Well, yeah. Yeah, okay. So this is, I guess it's tied to an image here, but I don't think it needs to be. Like, I think the way that NVRHI is architected is it doesn't really need that. So this is just going to be MIP. Wait, so this is just a single MIP, this image view? Yeah, it's just, I guess this was like an ultra specific use case for this, which is why I didn't expand it. It's just a single MIP. It's not a MIP range, and it's not like you can't select layers. It's just like which MIP would you like? So number MIP levels is going to be 1, and base MIP level is going to be MIP. And I guess, like, what did I have here? Layer count 1. No, wait. I had layer count image spec.layers. Okay, so we need to get the layer count from there probably, and base array layer is 0. So we have to basically do this. We have to do m specification dot image get specification dot layers, I think, to get that. So we do need the image, I guess, in this case. Yeah, and then this just does m specification, and then did we have it? Yeah, so it calls invalidate. Yeah, that's it. Nothing special at all. Obviously a lot simpler with NVRHI. So now it's stored in this texture sub-resource set. That's kind of it. I guess I could make this a little bit cleaner, maybe. And it does create a descriptor image info, but yeah, we'll see. We'll cross that bridge when we get there. So I can probably delete this now. Vulkan image view. I think all of this stuff probably doesn't need to exist. Like we probably want a way to convert the two from NVRHI formats to Hazel image formats, because these here are Hazel image formats. But yeah, we will see. Okay, so I guess we can now move this up. So I'll basically cut this, I think, and then just go to Vulkan image, sorry, to image. Yeah, so see, we have a bunch of this format stuff that's generic here. But the thing is, I have to kind of combine it with this class. So let's maybe not cut it just yet, because I'll leave that to do. Because I'd rather do it manually, I think. So GPU allocation size, we'll see. This goes here. The constructors go here as well. There's just one. Create, we should have static. Is there a create function here? No, that's weird. That's very weird. There's no create function. Okay. Oh, image 2D. Oh, shoot. Yeah, this is where it goes. Ah, okay, my bad. That's fine though. This can remain the base class, I think. So we'll have this virtual. I can keep it down here. And then this goes away. I forgot about different images, such as 2D and cube and 3D. Okay, so this goes here. There's that create function. It's here now. Oops. How don't you get confused working on Hazel and having other people as well programming stuff here? Just, I don't know, experience, time, like learning, you know, you get better at things with time. That's how humans work. So there was a time when I was younger and less experienced when like working on stuff is overwhelming. And also it does get overwhelming sometimes, but you just gotta like remember to just chip away at it and don't let yourself get too overwhelmed, because otherwise, yeah, that makes it worse. But this is not too bad. All right. Yeah, so I got that create function. This stuff is not virtual anymore. So this calls all right, this is just another function. Okay, but anyway, from now I think I can basically copy all of this stuff. I think I'll keep those two up there. And yeah, just this needs to go away. So there's that function. So I guess we can get rid of it. And there's two. I didn't see the other one. Oh, the other one's probably an image, isn't it? Yeah, let's get size. Well, yeah, I'm sure it's here. Maybe it's not. There it is. First one. Yeah, so this whole GPU allocation size, I guess it can just be a UN64T. Put that back. I don't know how to get that from NVRHI. They were gonna have to make sure that we figure that out. This stuff's already here. NVRHI stuff, virtual override. We don't have any implementations here yet. Actually, I should be careful getting rid of stuff because I forgot this. I mean, some of these actually are gonna be virtual functions, because we have all of these inside the base image, which we do want to overwrite. So we will see. It's only stuff that was in image 2D, which wasn't even that much, was it? If we have a quick look at this, resize and is valid were the only two functions I think here. So that means that is valid is not const override anymore, and the other resize, I think one of them is and one of them isn't. So should probably just have both. Like, you know, this one should also maybe be here. That way they can both be override. And we have both of them in image classes. Why is that not in the CPP file as well? As interesting. This one here. Okay, cool. So yeah, so everything else actually does stay virtual. I guess I probably would have like said we need to grab, yeah, basically all of this stuff, right? It's not that much. So what's this if old? Oh yeah, that I wanted to keep. Okay, sure. So let's grab all of this and dump it into, so that doesn't exist anymore. We'll dump it here. And then Vulkan image 2D is just going to become image 2D. Get image refs as image references, because they're supposed to be VK image. Okay, so this will become, see, that's annoying because they're supposed to be weak refs. But if I store them as, what are they stored as? Where is the image actually stored, first of all? Because they'll be strong refs. Like, they'll be reference counted objects, I think. Where does the image actually get created? Create text. Oh, device create texture. M info image handle. Texture handle. But that's a strong reference, I think. I mean, that's a debug only thing, so we can probably get back to it, but I think it's probably still okay. Like, so a texture handle is, yeah, a reference counter pointer to an iTexture. So if we look at texture handle, ref counter pointer, this will have an underlying raw type that we can use, and that's effectively the same thing, right? I just need to find it. Yeah, here it is. So there's an operator for it, and there's also a get function, which I probably prefer. So, so basically, we can just do. Let me just double check one more thing. Yeah. So I think it'll just be an iTexture pointer, basically. Like that. Sorry, NVRHI. Let's not forget that prefix, the namespace. And then that means this will just be that as well. And then it'll be a weak ref to image 2D. Yeah, which I've already done. And then when we add stuff to here, because I don't have that. But when we add stuff to it, we can just do .get. So how come we're not adding anything to it? Let's have a look at where that used to happen. What was it? Image reference. Oh, so arrays used to happen in here. So that's, I guess that's important. In release. Well, I think I kept release, yeah. It's not image data, is it? It's... info. So info dot image. It's like texture image handle. All right, dot get. So we'll raise it here and then we add it. Where do we add it? In RT validate. I guess when we create it basically, so after we create it, I think we can do equals this. And so it'll just be a weak ref to an image 2D, which is the current object. That's it. That's good, I think. Why do you write keep virtual when you override a function isn't useless? Yeah, but to me it adds a bit more clarity to the code. I just like being reminded that it's a virtual function because override's all the way over there. You know, you can't even see override half the time because it's like if the function's like long or whatever, you know, and you're working in a thin kind of viewer, you might not realize, but here I can easily see like the stuff is virtual, you know, without having to see the override at the very end. So I kind of like it. Okay. Is that, okay, so let's see all the other errors. So get hash, we hash, what do we use this hash for? Because this is just gets the UN64 with the Vulkan handle, which will basically be different every time. So we probably could effectively do image handle, dot get, and then cast it, so that's the pointer. Cast it to a UN64T and that should be all right. Yeah, that just hasn't compiled yet. Resource descriptor info. What is that? What are you? M descriptor image info. That doesn't quite exist anymore. Yeah, making all this stuff work is going to be fun. Like, just porting it and having it compile is one thing, but actually having it work is going to be an entirely different thing. So I hope you guys like this kind of stuff because there's going to be a lot more of this over the coming like months probably. Okay, yeah, descriptor image info is just basically, it's used to be this, so I guess we can just do image info probably. But why is it being cast to this? Oh, that's a void pointer. Well, yeah, just because we want to. Yeah, so yeah, I think just m info is kind of what we're looking for, and then we won't do anything for this. I think because that seems silly. That should work. But yeah, again, when we actually start using it, I'll be reminded of why it exists in the first place, probably, and then I'll be like, that won't work or whatever else. Okay, is valid is already defined apparently, and we have is valid. Oh, okay, so let's get rid of it from here. Syntax error. What's the syntax error? Missing. What? What's missing? We're missing a semicolon apparently. I think image info is probably not defined because it's up here, so. I'll put it here. VK clear value inside frame buffer. Frame buffer comes up all the time. Yeah, that's because the renderer includes it, which is a bit annoying, but let's just skip that. Is valid in, okay, so yeah, so Vulkan image 2D, I think in Vulkan image, we'll probably just delete now. I mean, it's got so much stuff in it. And like, you know, NVRHI format, we need to keep. So that's inside like utils. So let's have a look at image.h. Let's have a look at utils. I'll put it up here. And that stuff I don't care about. And this is gone anyway. Okay, cool. So that's it. We now delete the Vulkan image, which is cool. And we are left with just image. Get rid of this. Frame buffer, frame buffer. Okay, image cannot do something. I guess I didn't have a destructor. Applications, not a class. Name, so we'll include Hazel core application. Renderer. Submit. So yeah, so this is where the renderer actually needs to exist here. I think we're actually including it in here for some reason. It actually doesn't look like we are, but I thought we were. Maybe it was in here or something weird. I don't know. Why does that include mesh and scene? What? I don't know, man. Oh. Why am I out of focus? That was weird. Stop recognizing my face as a face for a bit. Thanks, camera. Yeah, so I guess we can kind of start looking at Vulkan frame buffer. Let's have a quick look at, in general, let's just do a compile of everything and have a look at how stuff's going. I bet half of this is going to be stuff from, so 605 errors, so that's, we had what, 1,500. So not bad. A lot of these like image no overloaded function takes 2 arguments. So I guess we have to do image2d create, but I thought we had I thought we made that work. I mean, we should have. Or do we not have that constructor? Is that why? Yeah, we don't have the constructor. See what you have to create. Oh no, it's a yeah, it's a default parameter. But I don't get, so how did it used to work? Oh, we just had that. So what's up with buffer then? Did that used to exist here? Yeah, and it used to go into here. Into create. Ah, it never used buffer. Let's create with a specific. Let's create with just a spec. What? That's wild. But image2d create. Oh no! Wait, we added that. Yeah, there was just a create function that did take in buffer, so that's what I'm kind of looking for. Create function that takes in buffer. Let me just maybe look at this side by side. Otherwise, it's very hard to follow. And that proceeded to not use the buffer. That's it. Okay, so the buffer was a lie. And we did get sucked in. So there might be some API that uses that, which would be wrong. But that might be better. If I just do that. All right, let's have a look. What's this music blessing my ears right now? It's the Deep Focus playlist, Epidemic Sound. If you go to like Spotify, type in Deep Focus. It's the Epidemic Sound one. Then this is what track is this? Till Dawn by Lucas Scott Lucky. That's what's blessing your ears right now. That and my voice. All right. Apparently create here is also an issue in vertex buffer. So this is what I mean, like all this API stuff I kind of want to fix up. So yeah, like how did we go wrong here? So now we have either buffer or size. Oh, you know what it probably would have been? I think it would have been the fact that, yeah, we just had a void pointer and a size separately. Now it has to be a buffer. So in those cases, we actually have to go back here and basically be like, nah, this has to be a buffer. Which makes a bit more sense. Yeah, a buffer is those two things, so it's not actually changing anything really. It's gone. Texture. So this class, I think I really have to rethink the way I do images and textures because they're like the same thing kind of, but they're different and it gets difficult. And this actually uses an image and this obviously still, so I haven't done Vulkan texture yet, so I guess we won't look at it yet. I'm just looking through this. This just can't open files. Yeah, frame buffer. Frame buffer is probably the next thing we're gonna take a look at, which I'm not looking forward to be honest. Because it's gonna be a lot of stuff. Oh, thumbnail generator. Just trying to use Vulkan image directly, which it naughty shouldn't be. What was it using that for? Oh, this. Oh, okay. It can probably just ask to see. Can't you just get the handle? We should probably allow people to just get the handle. There's no, there is a get handle function. Yeah, okay. So that should work. If that's false, if that's null. Are we happy? No. Because of frame buffer. Alright guys, it's time to rewrite frame buffer. Oh, rewriting frame buffer is going to be the worst. So, let's go to the Vulkan frame buffer. And I'm probably just going to start rewriting this. It's not that bad. It's just 400 lines. It's just very like specific, obviously, because it's a very specific part of the rendering. Do you have a reason for having so wide lines and not using line break? Well, I don't know. I mean, first of all, I'm in a big font. Like 100% is that big. I don't really program at 100% ever, probably. Maybe like 120 at least. But because I'm on stream, you know, I'm zooming in for you guys. So it makes it seem worse than it is. But I don't know. I do break apart sometimes lines, but if it's like a function definition, I try not to. I mean, I suppose you could break this up a bit, but yeah, I don't have a good reason to. Like, as in, I probably should keep my lines a little bit narrower. Okay, so what's your issue? So this is trying to get attachment load operation because we're trying to set it here. So yeah, so basically, I guess we'll just start with RT invalidate, and we're just gonna go through and basically port everything to NVRHI. But you can see that a lot of this is just very like state kind of driven. It's just like based on what you have inside your, your specification, it's going to create the exact frame buffer that you want, including using like existing images or even an existing frame buffer, or probably like layers of that image or whatever. It gets complicated because sometimes we want to take like, you know, sometimes you want to create a frame buffer that's like, it's the color attachment from that frame buffer and then the depth attachment from this other frame buffer. And anyway, it gets complicated. Well, we know this doesn't exist anymore. So yeah, so some of this stuff probably is not too bad, because like, for example, this tells us we need to create a depth image and we can just do that. That's fine. But we need to really have a look at how frame buffers, like what they actually look like in terms of NVRHI. So we have a frame buffer description and then we just add attachments to it, I guess. And then we also have okay, there's a shading rate attachment, we don't care. And so it's got a depth attachment separately, just like we do, and then we've got a bunch of these frame buffer attachments, which are specific textures, as you can see, and so it's an architecture pointer, so it's like, I guess it's a weak reference to a texture, which is correct. And then it's a texture sub-resource set of sub-resources. So 0101 just means, I think, yeah, base MIP level and only one MIP, and base array slice and only one slice slash layer. Okay, I wish I didn't close that. Yeah, that seems pretty straightforward. It's basically like a one-to-one mapping, I think. We just need to create like a frame buffer info and yeah. Okay, cool beans. Are you using modern Vulkan features like dynamic rendering or dynamic states? No. I don't like think I really want to. I think dynamic rendering is like good if you're trying to just make a little Vulkan app, but if you're making an engine, you might as well implement rendering properly. I think that like being verbose is not necessarily a bad thing, you know? It like I'm pretty sure dynamic rendering was meant to just make stuff a bit easier if you don't need as much like control or something. But Hazel, like, because Hazel's renderer was written initially and the Vulkan side and everything before dynamic rendering was even a thing, it doesn't make sense for us to like stop using this and move to dynamic rendering. Okay, so unless there's a good reason to, which I'm not aware of. Okay, so what am I doing here? So attachment specification dot format. So what's wrong with this? So NVRHI format. So is depth format. It's supposed to be image format. But why? We've just made this an NVRHI format. I don't think I should have done that. I probably should not have done that. Because we still want to keep Hazel's API separate from NVRHI in case we move away from NVRHI in the future. I don't want to tie us too closely to it. Not to mention we can have a smaller subset of formats we actually support instead of supporting everything that like Vulkan, I guess, and DirectX support, which probably NVRHI would have to implement because they don't know the specific use case. So this is in fact supposed to be image format. I probably can go back to just being image format, which is Hazel's image format. Which, yeah, means that we have to have that conversion, but that's okay. Oh, that's the wrong one. Yes, we will have to convert from Hazel's one into here. Okay. Yeah. Okay, so with this whole VK attachment description, this is us creating it, and we're also setting a clear value. That's a bit annoying. So let's get rid of this for a bit. And then we're effectively looking at frame buffer info. So what's frame buffer info? Frame buffer info. Okay, that's frame buffer description. So we're making a frame buffer desk, I guess. Frame buffer description. Let's just do this. So this will be a, I guess we just set it up like that. And then we'll do an NVRHI frame buffer attachment, which is one of these. And so for this attachment, this is like a color attachment probably. We have to set up all these things. So it's gonna have a texture, I guess. Have we determined that yet? So I'm interested in stuff like these load operations. How does that get set here? Because it doesn't look like it does, but it needs to be somewhere, right? So it's got a format, and it's got an actual texture, and that's kind of it. I wonder if the load operations happen at the frame buffer level, but it doesn't look like it. Maybe they happen... I don't know, yeah, it's a bit weird. I guess we'll cross that bridge when we get there. Okay, so format, I guess we can set, so it's gonna be this, but we need to go basically utils. What have I been calling the conversion function? So if we look at, I mean, we probably already have that in image, right? Like, what do we do for image formats? NVRHI format, and that's inside image. So utils NVRHI format is basically the function. Okay, so that's the format. Do we attachment description? That's but how we actually attach it? What was this if? Oh, this is if it's a depth format. Okay. So this is for a depth attachment. I guess I'll just make that clear because it means that into our frame buffer description, we basically end up setting the depth attachment to. I guess we could just do this. Save a line. I mean, yeah, the thing is, we don't care about layouts because that's handled internally. Yeah, but what about like these store ops and like, this is important stuff. Where does this happen? Load op? Does NVRHI try and like work that out itself somehow? I don't know how it would, considering that's up to the user to decide. Let's just have a look at set load op, attachment description to create frame buffer from frame buffer description. Okay, so load and store, they're kind of set automatically. Yeah, oh, this is Vulkan. Yeah, so it's set automatically here to just load and store. I mean, that is the most common thing to do. I mean, you can see we actually decide whether or not to. Oh, well, actually, yeah, because clear versus load, though. Load op, clear, and stuff. So there's load, and then there's clear, right? Because there is clear. It just does load, though. But that's not... We need to be able to clear, I think. I mean, we could do an explicit clear. It's either that, or I could obviously go into frame buffer description or into specifically the color attachment description and then add it, you know? So I could basically say that you have to specify it. I could add it to if we end up needing it, I could add it to frame buffer attachment. So there could be like, you know, store op and load op or whatever. I don't know how that would map to DirectX 12 or 11 though. Yeah, I'm not sure what to do about that. But yeah, well, okay, we'll see. I think we'll see what to do about the whole load up and store up stuff. But this is important. Like that's as far as I remember, this like it's important. It's obviously important. Like it's definitely used. So by default, it's set to clear color on load and clear depth on load in Hazel. And I think like if we search for these things in scene renderer, you can see they do get set to false sometimes. So clear depth on load, clear color on load is false for the geometry frame buffer apparently. I don't know if that's because we do some kind of explicit clear or there's a reason for that. And you can see that, for example, even this attachment specifically has a load op of load. So don't clear primary color attachment because the skybox passed writes into it. So, see, this is important stuff. But it looks like what it would be doing is just like where is it? Let's go back to here. Is just setting it to what, to load, and so what, to never clear. Well, I guess, okay, so I guess if it always does a load, then you can tell it to clear manually. Because you can't, if it cleared, that would be destructive. But since it loads, but like, how do you tell it to clear? Through NVRHI. No, this is frozen. Oh, that was, did you guys see that dialog box? It was like empty. Let's go search for clear and see clear value. Sure. There's not really. Oh, command list clears the graphics. No, it's not. There's all this stuff, but there's no clear texture float, clear texture uint. Clear texture. So what does that do? So yeah, clear color image. Okay. Oh, but that's not really that efficient, I think, compared to just doing a load op clear. I don't imagine it would be. Okay, well, anyway, I guess we will have to get back to that. Like, once we actually have it running. So I'll just do like a little to-do. What about load store ops? Maybe I need to read more about NVRHI and see if it supports that in some other way that I'm not seeing. But otherwise, it looks like that's basically this. And then, yeah, we need an image associated with it. So it will basically either use an existing one or it will create it. And then we're supposed to do something with it. So yeah, so this is us creating that basically. Right? Or getting it from an existing image. So we have it here. It's this. So that means that we can do depth attachment dot, is it like texture equals m depth attachment image get handle. And then what else do we need? The sub resource set, which I'll just leave. So that's it. That's our depth attachment sorted instead of all this apparently. But again, it doesn't, so we don't have our actual clear values, which we need to, I guess we need to set our depth clear value. But again, this clear values is just something that we had a vector of here. So VK clear value is union of these two things, and for depth stencil value, it's like a float and a uint. We might need to kind of steal that union. Because I think this is an int, right? A float and an int, yeah. Okay, let's steal that. Okay. Why is this just a verify false? Is it, I guess that path is broken or something. Nice. Okay, and then this is the section here. That we don't do. And instead we do... Let me just grab it from up here because it needs to be the same. I'll be a bit more precise with my naming. And where does that go exactly, that attachment description? Like, what? Oh, it's here, sorry, I missed this. So that's what it is. Yeah, these need to be that. So texture and wait. Great. Just do that for now. And then this will be, yeah, obviously that, and yeah, this stuff I need to deal with. Where's the actual, what is the actual, it's called color attachment, isn't it? So color attachment get handle. I'm guessing. So color attachment is the actual image. So I might just refactor that maybe to color attachment image. And then that way I can get rid of the desk here, because that actually is not just a frame buffer attachment. So that goes into here, but then we have to attachment index, the subpass stuff, which I'm sure we don't need. Subpass dependencies, that's all stuff that I'm sure it does for us. And the render pass create, I don't think we need any of this. And then here are all of the attachments, basically. So we can kind of get rid of all of this, I think. And because now what we have is we basically have a vector of color attachments, and we have which are in attachment descriptions, and we also have the depth attachment. They actually might be all in a row. No, because that's just in frame buffer. Oh, we already sort that out. So what's the thing that has stuff here? No, frame buffer description. Oh, okay, so it's this, yeah, it's a static vector of color attachments. And then it's got depth attachments separately. So I don't think we need that vector. So this attachment, this vector of color attachment reference, what? Attachment descriptions. This vector of attachment descriptions, I don't think we need this. I think instead, when we use it, which is here, because we have an attachment index, so we just do color attachments, attachment index ++. We just park it right in there, I guess, right? And this is in frame buffer description. The only thing is attachment index, does that increment if we hit a depth attachment? Yeah, it does probably. But I think it might need to because of this. Yeah, I don't know. I guess it is definitely cleaner to just combine the two. But obviously, eventually, in all the rendering APIs, when you create it, it's like, okay, where's your array of color attachments and then your one permittable depth attachment separately. But the reason why I didn't separate it, and for me, it's like you make a frame buffer specification and then all the attachments are just, like they include the depth buffer, is because when you create something like this, see, you can just be like, here's my frame buffer specification in Hazel, here are my attachments, and then you just list all of them out, RGBA 32F, 16F, RGBA, for example, and then the depth stencil. So this is like all 4 attachments immediately. Whereas if you had to do like dot color attachments and then these 3 and then dot depth attachment, that one, it just makes it a bit less clean. So generally you would put this last, but it's still, obviously, yeah. So I don't know, but the clear values are where the attachment index kind of matters. So it's a bit annoying. I think the way to solve this would be to probably have an attachment index and then also like an NVRHI attachment index. And, you know, or actually you could just have a color attachment index. And that way your color attachment index only increments if it's a color attachment. Or you could, maybe I will actually call it NVRHI attachment and then I'll only increment it here. Because that way you're only going to do it if it's a color attachment, and this branch, I believe, is the else of the depth format, right? Yeah. So that's probably better. Does adding NVRHI mean ray tracing will be easier to integrate to Hazel? Not really. Cross-platform, like cross-API ray tracing, yes, like so DirectX 12 or Vulkan. But in general, like, so Hazel has a ray tracing, has a path tracing branch that is just uses Vulkan ray tracing that I did like 2 years ago, probably. So I guess one day I'll probably port that over into the new API, which will use NVRHI. But no, I wouldn't say it really makes ray tracing that much easier. Maybe like a little bit in the sense that it makes Vulkan easier because you don't have to write so much Vulkan. But you still have to write all the ray tracing code. Okay. So yeah, that's probably it in terms of like, okay, we've created our specification in frame buffer description. So now we have to actually create the frame buffer. So to do that, we would probably create it, I imagine, like we would create an image. And we do that by, how do we do that? So we have a device here, so we need to get this device handle. And then we do device create texture. So I'm guessing we would do device create frame buffer. And we would pass in the frame buffer description and we're done. Device probably already exists in this context as a Vulkan device. Okay, VK clear values, so get Vulkan clear values. So didn't I make these different? Oh, that was in Vulkan. Right, I need to combine these two things. Wait, did I already put stuff here? Like, why does it have all this stuff here? That's odd. Because doesn't this have no implementation? Oh, well, it seems to have quite a lot of implementation. Wait, did I already paste this into here? Wait, look, I already wrote this code differently. I mean, I used this instead, but dot set format and then dot add color attachment, but I didn't do the actual things here. And then I did device create frame buffer. So this is, I already pasted all this stuff here. Okay, it doesn't matter. We're gonna ignore this because I did it worse. But that's why it's here. So now, yeah, now we're just gonna do kind of what we did before, where we're just gonna go to Vulkan frame buffer, which is here. And we're just going to basically grab this stuff, paste it here. We're gonna grab this stuff and, you know, most of it, I guess, goes here. Yeah, so that's just that. That's just that. Nothing here is really virtual anymore, and override we will. I guess I'll look through it. Bind unbind is from OpenGL days. Bind texture as well is not what we do around here anymore. Yeah. Do we have a get handle? I guess not. Wait. Oh, we didn't store this anyway. Yeah, we don't have that. So M handle, I guess, is just that. So let's do NVRHI frame buffer handle equals null. Do you know, are there any other similar libraries like NVRHI? Probably. I haven't really looked into other alternatives, to be honest. But I would expect there are probably other things that abstract backends. But I really liked how close this was, like, to the actual API. Because there are more high-level options that I'm not, like, that I probably wouldn't be a fan of for this level that I need, you know? Okay, so that's all there now. So we just have to basically nuke this CPP file. Because I think it's all in there, right? Like, it should be all in here. That's all the same, right? Yeah. And this is stuff that we've written. So yeah, this whole namespace utils, I'm gonna pop it up here and be like, we need to deal with this. And then everything else is just gonna, I'll cut it and I will replace basically everything here with that. And then we're gonna rewrite that. This is handle, but this, I guess this doesn't really exist anymore, does it? The problem is we might have to release certain images which might have strong references. So again, we'll deal with this, if deal. We'll deal with that later. Oh, swap chain target frame buffers. Ugh. That's something we also need to deal with. And Vulkan allocate, I guess that doesn't quite exist, does it? Because, will NVIDIA do that tracking for us, I wonder? You have two destructors, do I? Yes, I do. I think I'll just leave this as default for now. The thing is, I guess we kind of have to not do that. We probably have to release just because, do I have a destructor here? I do, yeah, and it calls release. Just because, yeah, we might be... This should happen, I think, to an extent by itself, but it's definitely something I want to make a pass over when it is actually running and I can step through it. Yeah, this whole swap chain target situation though. So basically frame buffers can kind of be not a frame buffer and just directly target the swap chain in Hazel's API. No idea how that's going to work here. It's basically good because what it does is it just takes the render pass from the swap chain. So, yeah, this is something that I will have to deal with later. Okay. So let's make sure everything here compiles. So clear value, what's the problem here? Undefined, because I think I have it here. Yeah, and then we can, I think that's it. We can, so now we can delete Vulkan framebuffer.h and .cpp, which is nice. Okay, so next up, let's compile this. Still one little error here. Yeah, from the allocator, which I guess we don't use anymore. It's still like, you know, color attachment references, which, oh, right, okay, we had it here. So that, yeah, that's gone. We don't need that. And depth attachment reference, we also aren't using. So let's give that a compile. Private, okay. Forgot to make this public. Okay, frame buffer builds. Does it work? Probably not, but it builds. That's good. Okay, let's do a build all. Wonder if we can get this building today. I mean, even if we do, it's not gonna run, but... we can maybe try and get a building. That would be nice. It's been a while since this branch built. If we can get a building, I might commit. That's how far I'll go. I think we're getting reasonably close to getting this building, just judging by the amount of red I'm seeing on screen. 36 errors, it's child's play. Yeah, 33 errors. Okay, and a lot of them are just, oh, texture. We haven't done anything with the texture, have we? Oh. Or have we? Oh, look, we have. Why did I do all this work? Huh. Oh yeah, so we have to, oh yeah, I remember this. I remember working on this. But invalidate doesn't seem to do anything, does it? So why did I implement set data and not invalidate? Bit weird. Wait, or maybe I did. Yeah, I did. This is all an NVRHI stuff, right? No, it's not. This is, yeah, damn. I was happy for a second, now I'm not. But I did start on this, which is good. So let's, I guess, continue here. Oh yeah, the linker errors. Well, I don't know if we'll have that many linker errors, to be honest. Probably just from functions we've removed. So we create an image. This is just doing transition stuff like for the image layout, which I guess we don't need. This sub resource range, that's for what? That's for, I don't think we need that. From undefined to what we want it to be. I don't even know why it's doing this, to be honest. Let's not do that. Create texture sampler owned by image. Well, sure. I guess we can steal this. Image does a similar thing. So if I just find this, then we can basically just be like, you know, let's do it here. So we'll set the min filter and the min filter and whatever to, oh wait, is this supposed to be true? Oh, it's just true or false. Okay, sampler wrap, clamp to edge. Do we have something that translates that? I mean, obviously we didn't, we just set it to clamp to edge. So, and then that, yeah, sure. So if it's integer, yeah, we still probably need to do that though. Let's just change these. Oh, it's in this file. Okay. Sample address mode, and what was the other one? Oh, it's just true. That's right. Okay. So that'll be a boolean then, I guess. Where am I? It's up here. No, that's this. This is the boolean. And this is NVRHI sampler address mode, probably. Yeah, clamp. That's nice. It's got like both the DirectX and the Vulkan names, so you can do whatever you want. I guess I'll do clamp to edge. Wait, we called it clamp though. Yeah, whatever. It's the same thing. And then repeat will be wrap. I guess I'll call it repeat. This is a bit weird, but whatever. Oh, I keep forgetting that's in the same file. And then, yeah, with this, so I guess linear would be true. Cubic's probably also true, and that's a different filter. I don't know, it's just... The filtering is just true or false. Like, true, I guess, for linear filtering and false for nearest. So, let's do something like, I guess, this. And then for this, we'll do false. Again, I kind of want a different way to deal with samplers anyway, so this I think will be somewhat temporary, but yeah. Okay, so, I don't know why this has anything to do with it being integer based. I think you just set it here. I mean, that was an image anyway, but whatever. So this will be NVRHI filter, right? And then that will be specification sampler filter. Yeah, min load, max load. I guess we set. There's no max, there's just bias. So we'll leave that off. Because min load is 0. And mip load bias is 0. Why is an isotropy off? That's weird. Wouldn't that make things look nicer? Each texture creates its own sampler. Yes, maybe at the moment. I don't know if images don't do that though. Yeah, the reason why is because OpenGL, OpenGL before a specific version didn't have sampler objects, so you had to set it per texture, and so I think we are still on that design, unfortunately, but yeah. Are there any published games that use your engine? Just Game Jam games. If you go to like the Studio Cherno itch.io page, so it's like studiocherno.itch.io, then these are all games that, okay, except for Genesis, that's a 2D game I made in Raylib, but these are all like games that, you know, I made in, well, this one I made by myself in like, you know, this is all rendered in Hazel, using assets I didn't make either, so it's not very impressive, I know, but these are all games that I made in like a few days. Usually to test out Hazel. The other ones I made like, so this one like I made with Tim and Peter, who used to be on my team. So this is probably the best game we've made, I think, in terms of like actually a good game. It's called Dichotomy, it's like a puzzle game. This was a while ago. This was like 2022, 3 years ago, 2022. So yeah, we've made a few games that you can try out. This was like a stupid little RPG type game, bit weird, but kind of fun. And then Fragile was a little game that we made the day before a game jam, just to see if we could actually ship something. And this is even more dumb. Oh, and this is another game, yeah. You have to deliver coffee while fighting enemies. Any third-party games from other studios? Well, Hazel's not really out yet, like, so no. Someone actually made another Game Jam game, I think with it, they sent it in for a code review. I might do a code review video on it. I haven't actually looked at the game yet, but they did, I think, the most recent Let 'em Dare, and they decided to use Hazel because they, I guess, were a patron and had access to it. So I might do a little code review over that if people are interested. That might be fun. But we're working towards releasing Hazel at the end of the year for free to use. So at that point, some people could do it. The Hazel project of these games are available somewhere. No, I don't think so. I used to do this thing where I made like partner patrons. So there's like the highest tier of patron is like $25 a month. And like for those, I used to give them access to all the games that we worked on. So I think actually, yeah, we made a Space Invaders game. I forgot about that one. Well, yeah, we made a Space Invaders game. Tim made that mostly. And that is very old. But that we made available to like partner patrons and stuff. I should probably do that with the rest of the Let 'em Dare games, because it's not like I care about them or anything. Like, there's no reason for them not to be available. But yeah, I'd have to make sure they work with current Hazel though. Thanks for the kind words, Nightwing. Why don't you support OpenGL? Well, there's no real reason to. We used to, but it's just a lot of maintenance and it's not worth it. Yeah, we used to have Vulkan and OpenGL. Oh yeah, which engine would you compare Hazel most to? In concerns of how to develop with it, is it like Unity? Well, yeah, we kind of I want to make it as kind of as simple to use as Unity, I guess. But we want to, yeah, I don't know. I don't think you could compare. Like, I think Hazel's kind of taken on its own unique flavor at this point. I don't think it's that like comparable to other existing engines. It's just Unity's the easy comparison, I think, just because C# scripting, we support C# scripting, and it's kind of similar to Unity's API. But other than that, yeah, Hazel is Hazel. There you go. Okay, so where does this silly sampler live? In info.sampler. So it's, yeah, like the same thing, but just that. Except, yeah, device is not this kind of device. Ah, this is why we used to enable. I didn't see that. And we just decided not to, weirdly enough. Okay, let's jump up to device, and then we're gonna get rid of it. Yeah, this whole storage situation, if it's not storage, we create a view for it. I don't think we need to do that either. I think it has that texture. When you create it, it should have that texture subresource set that gets created automatically, so that should be fine. Alright, cool beans. What do we do now? There's still quite a lot of stuff here. I don't know what is this? Oh, I just redirected to image. So that will just be this, I guess. And then, texture cubes, lol. Cube maps. I guess we sort that out too. Cube maps. Oh, but we don't... Cube maps should be fairly easy, I think. Cube textures. We do have references to them and stuff. Local storage. But we don't do this, do we? I don't think we support this. Kind of looks like we do, but what? Or is that just never a thing that happens? If data. We don't ever do this, I think. Because we generate cube maps. And I don't think we support taking it in from like a T-pose, you know, or anything. I think you just need to pass in an equi. If you want an HDR, you pass in an equirectangular image and it runs some compute shaders to sort that out for you. So, yeah. Ah yes, the Hazel. The game engine I've been working on. Sounds familiar. Okay, yeah, and we don't have image cubes, we've got texture cubes, so this is important. So let's figure out how we do this, because I'm actually not too sure. So the texture dimension cube exists, and that's probably it. And then where's that used? In texture description. So I think we just create texture description. I think that's really all it is. So we need to make this NVRHI, oops, texture description, and then we can do dimension. Cube, texture cube. It's probably gonna have a format. And apparently has a MIP count. Array layer 6, obviously. Do I have to write that, or is that obvious because it's a texture cube? Array size. Well, it's not an array though. Array layers is not. That's different. I'm gonna assume I don't have to do that, but we'll see. Extent. Nah. What else is in here that's important? I guess MIP levels. Maybe I can just, since that's gonna be accessible, can just do that. And that might be it. Yeah, this stuff, I don't buy any of this stuff, this image copy stuff. I don't think we need that. None of this matters either. Let's go down to the sampler. Let's create this, obviously. So let's go back to like here, grab our device, create texture. Oh, this is all in Vulkan. We gotta pop all this back eventually, and it's already got a handle. That's nice. Yeah, let's find that sampler stuff. Make sure we have that. Okay, let's do... I don't know about that image view stuff as well. Yeah, that should be automatic, I think. So let's just do this. And where do we store the sampler? in descriptor, which we don't really have anymore. I'll store it here, but we'll see. I don't think we even need it, to be honest. I'm guessing this is basically the same. Okay. Yeah, we probably don't need it, but we'll see. Yeah, this whole releasing stuff should also be deal, if deal, because I got to deal with it. I'll exclude that. Okay, so now I think we can do our thing where we just go to just texture.h and we get that stuff in there. Wow, so much stuff. Yeah, so we got that. We got the resizing and validate. I'm just looking for stuff that's specific. So void and validate apparently. Oh, and then there's all this stuff. Oh, this is override. Could be from the base though. And copy to host buffer. Everything else is virtual, so an override. So it'll probably be in the base class. Oh, I'm getting sleepy. Texture cube needs a bunch of stuff though. But why? A lot of, I guess they're just overrides from, yeah. I probably should have just taken everything. Because a lot of this stuff I think, well maybe not actually. A lot of this stuff I thought might be from the base class, but whatever, we'll figure it out. Yeah, this stuff is basically all from the base class. Because it, oh, from texture cube. Yeah, but it's also from texture, because texture cube doesn't add too much. And texture does have a bunch of stuff, so that's probably important. Bind is still a thing here, comically. Okay. This whole single, yeah, this needs to be implemented, I think. Because that actually might be useful. All right. So now we can kind of get rid of most of this stuff. That goes away and this goes away. And then we kind of have to grab all of this. Pop it here. Pop this into a more appropriate place. erase all this. I don't know why we have a create with a file path. That's weird because the texture importer does that. Two buffer from file, two buffer from memory. So that's a bit weird. But oh well. Guess we'll see. I mean, it does have a create from file function somehow. A lot of this stuff. Yeah, there's create from file uses the texture importer. I guess it's just like a convenience function or something, but yeah, it's interesting. So where that importer is in Hazel asset. Yeah. Render submit. Why is image like not what? Maybe this is wrong. I said data doesn't exist here. Huh. Weird. Bind lol. Texture cube. We'll not sort that out yet. No, we did, I think. Yeah, I'm probably gonna get rid of this. Fine, we'll leave it for now, but I don't think it's good news. Yeah, it's very weird syntax, isn't it? The whole equals 0, like the pure virtual function thing. It's definitely very weird. Someone didn't know how to express it in English, so like, you know what, just make it 0, like that makes sense, yeah. Don't know why invalidate is private, but whatever. Ugh, my camera overheated. Lol. Enjoy just me for a bit. I mean, just me. By just me, I mean just the screen. So, didn't think it was that toasty in here. Soz. I'll have to talk more now, I guess, to make to make it seem more engaging. Okay, so this create image view single map situation. It's pretty easy. We just need to probably find where we made the whole sub resource set situation like this, because this I think now returns that. So I think we just make one of these and we just say that we want base MIP level of MIP. Number of MIPs we want 1. And then the layer situation, layer count is just 6. And base layer, I guess 0. And then I guess we just return it. That's it. There you go. Generate MIPS is, yes, something that we need to do, but I don't actually think we do that. My camera will work now because yeah, I need to investigate that, but I'm fairly sure that we don't do that because we do the filtering using compute shaders. Like we don't. This is a bleeding. This is an automatic bleeding using linear filtering, which we don't do. So I'm not really sure about that. Copy to host buffer, very important stuff, but I'd rather get the rest of the engine running first. So if deal. So I basically have to search for if deal in the future to make sure that all this stuff works. And I am putting some false verifiers here, just in case we hit those code paths. Already got that function loaded. Get path. Okay. Right. I think that we are basically done. So texture cube has no image. Yeah, yes, that is true. But I think this would just be a texture. Oh, sorry. Is it just handle? Yeah. And then dot. Okay, let's give this a go. See where we're at. Hey, what's up, Kurto? I'm not too bad today. I'm getting tired now, though. A lot of this kind of work, which isn't very energizing. 1,000 errors, nice. Back up to 1,000, guys. Cannot instantiate abstract class. Okay, so it shouldn't be an abstract class. So it means we probably haven't implemented something that we should have. Well, yeah, bind needs to go away. That's probably it. Because bind is from the OpenGL days. Okay, so let's see what we don't implement. Wow, a lot of stuff. Wait, really? We don't have get width or get height or anything? It's weird. Oh look, here they are. But wouldn't we have copied them over? So, oh yeah, we did. Oh, it's texture cube. Oh yeah, we didn't. So I guess all of this stuff. Do we have a get handle? No. Yeah, we just failed to implement a lot of stuff here. Make sure this builds. Yeah, get descriptor info. Do we need that still? Probably not, because we just have get handle. I think that basically makes up for it, so. But that's something that render a resource requires. So it probably just needs, I think this gets replaced with basically, there's something called like a resource handle. Like iResource or something, but there's something, I think resource handle is the type def of that iResource pointer. But you know, for now, just so we know, we could implement it, I guess. Why is this bad now? It's weird. Still upset. So get hash. I thought we had that. Oh yeah. Image. Texture cube is missing that thing as well. I want to make sure probably that we don't hit that accidentally. So let me chuck one of these in. There's lots of cleaning up to do, but I'm not spending too much time on that yet. No overloaded function. I hate this new view thing. From texture to texture 2D. Wait. Where is that happening? I think, maybe not. Is there no constructor that, I guess data is just null. So I guess this just has to be null. Okay, let's build this and see all the errors. Wonder if we'll get this building today. Okay, so guess what? I'm deleting Vulkan texture.h and .cpp. Delete. Gone. Okay. Now let's have a look at the errors. 36, not bad. Yeah, so this stuff should just be now this. Oops. And this as well. And this. Vulkan, I'm GUI. Okay. So what is this exactly doing? Ah, yeah, special I'm GUI stuff for that. And that's gonna be tough. Alright, I'll be back in a sec, guys. I'm just gonna go say goodnight to my daughter. BRB. Okay, I'm back. Did you miss me? So where were we? Oh, this stuff. Ugh. Okay, yeah. I don't know how this is gonna work. Like I think we're gonna have to rewrite I am GUI to actually not rewrite I am GUI as in I'm GUI, but the I'm GUI implementer, like the I'm GUI renderer, we're gonna have to probably rewrite using NVRHI. At the moment it uses Vulkan. So that's gonna be fun. Because there's probably no point doing any of this, right? Because what was it going to do? Like, it needs to give this kind of texture ID, which is going through this code. So all of this stuff is going to have to be NVRHI, basically, to render all the I'm GUI stuff. So that's going to be not fun. And then Vulkan I'm GUI will kind of cease to exist. So that's what that is. Okay, this stuff I think now just takes in buffers, which is easy enough. We're already getting some linking errors. Why are we getting linking errors? I didn't think we were linking yet. Yeah. Vulkan context. Does Vulkan image. This is the debug message callback. Any particular reason for using NVRHI versus your own solution? Well, just resources and time. Like it's, you know, I'm kind of outsourcing that part of things to, you know, not spend the time engineering it myself. But also, I don't think it necessarily needs me to do it. Like, I'm sure they're capable enough. It doesn't need to be super custom is my point. It's just an abstraction layer. Okay. This, I'm guessing, will just disappear, but I still want to be able to debug Vulkan properly, so we'll see how, I guess, we'll see how NVIDIA does it. Now, this, I think, yeah, did we move that? Because then this is just this, so. Do you have Blue Sky? No, I don't. Not yet, anyway. Not at the moment. I just use Twitter/X. And I don't really use it much. Like, I don't tweet very often. Okay, so Vulkan Compute Pipeline is something that we need to do as well. And Vulkan Compute Pass. What does Vulkan Compute Pass do? Just sets descriptor manager stuff. What? That's it? Oh, because it's kind of like a render pass, but it just does this. Oh, and that whole descriptor set manager is going to have to do some stuff, right? Because that's made specifically for Vulkan, isn't it? Yeah. This is going to be interesting. Have I ever thought about creating my own GUI library for Hazel? Yeah, I guess I've thought about it, but it's also like not... It's not something that I'm that passionate about, specifically, you know, making GUI libraries. So, you know, I like using... Sorry, microphone. I like using GUI libraries. Like, you know, I like to design nice UIs, but engineering a UI library, like, I feel like I'd rather spend my time elsewhere. And you really have to be kind of strict with, where you spend your time when you make something like a game engine. See, I don't really know how to change all of this yet, because this is obviously quite Vulkan specific. But I don't really know how we're supposed to manage resources and bind like resources and stuff using NVRHI yet. So I kind of can't do this yet. I don't think. Let's maybe have a little bit of a read. Have a look at both of these things. So we create a texture, and then we have to create, okay, so we create a binding set description, and we basically say that into, well, we add items to it. So this is like a texture, and this is a constant buffer. And then we create a binding set. Oh, right. Well, no, that already has the actual resource stuff. So then when we want it, we have to add a binding set to the graphic state. Then we set the graphic state when we render. Okay, so yeah, so basically this binding set is kind of what this descriptor set manager is. It's just, I don't think it needs to. So this is probably an example of something I'm gonna have to rewrite from scratch, because the way this is engineered right now is obviously for Vulkan. I wonder how that's gonna translate, like if that's gonna end up being easier or whatever. I think it probably will end up being easier. So then, okay, so this we don't touch then. Vulkan GUI we can't touch then. So what else is left? That's kind of it, I think. Oh, the compute pipeline and the compute pass. So the compute pipeline, let's see how we would create that. Let's just go straight to compute pipeline, and I'll create it there because this is kind of small, I think. We'll get rid of this. And then we'll get rid of all this stuff. Get shader. I don't know if this is something that we'll do. And these memory barriers, I think that's kind of happens automatically, so we'll see. Where's the constructor? I guess create pipeline is... Oh, there's quite a lot of stuff here, isn't there? Oh, wow. Didn't expect that much stuff. I guess it's not that much. Oh, RT create pipeline, where's that? Okay, so there's so much stuff here. I did not expect this to be this much stuff, but yeah, I think a lot of it, like this stuff, we probably won't need, but we'll see. That's funny. This is commented out. Don't. Okay, well, where's RT create pipeline? So I have to see how this works out, but compute pipeline description. Let's have a look at this. So it's just got a shader handle and then these binding layouts. Interesting. Need to read more about these binding layouts. But yeah, it's just got a shader handle, so it's a compute shader. I don't think. Oh, shaders. I probably haven't carried shaders across yet. Have I? No. Whoops. Did not mean to write that at all. I am pretty cooked. I might stop in a minute. Because I'm getting very tired. So what was it? It's just, yeah, shader handle. Any of those binding layouts or whatever. Would I consider making a video trying Rust? Yes, actually. That's on my list of things to do. I've never used Rust before, so it's prime content, I think. I'll just try and like make a game with it or something. I don't know. If you guys have ideas for what I should do in my using Rust for the first time video, then let me know. wonder if like, well, yeah, there's begin and end and execute, and I think, yeah, because, and there's probably dispatch as well, right? Yeah, dispatch. So dispatch kind of does everything. Oh no, that just does dispatch. So you're supposed to do that between begin and end. So you can do begin, dispatch, end manually, or I think you can just do execute, and it basically does the dispatch for you and all the other stuff. But this is crazy. Like, there's quite a lot of compute shader stuff that I did not think we had that granularity and control, but we do. So that's nice. Nice in the sense that I have a lot of work to do. Yeah, because RT begin binds the pipeline, for example, but execute just does everything. So execute will probably be closest to what we had here. I don't remember why we need to do it both ways, but yeah. So I'm guessing this would be like that, and then like just like how would you do a compute shader, run a compute shader? Create compute pipeline. Compute state. How's a pipeline? Set compute state and then dispatch. Didn't I search for dispatch? Look, it's not coming up. Oh, it's in a command list. Of course it is. Yeah, so you'd have to create a compute state. Which has the pipeline, the bindings, indirect parameters. You probably can create this ahead of time to not have it be an execute. And then if we go to like image or something, we kind of do something like this. We probably wouldn't create a command list. Well, we might, but not in execute. And then, yeah, you can do dispatch. And then before that, you would do set compute state. So that's roughly it. But then the descriptor sets and stuff, it's obviously going to be that where that binding set vector comes in, by all these binding sets and binding layouts, and I got to like wrap my head around that. I mean, a binding, so we create those binding sets, but what are binding layouts? Just the layout without the data? I don't really see that anywhere. Ah, here it is. Does it explain what they are? Yeah, it's just the layout. So it's just a description of the layout of all the resources. So it's like a descriptor set layout. And then the binding set is a descriptor set. So it's the actual data that matches that layout. So yeah, why do you want to try Rust? Just for fun. What do you mean? Like, why do you want to try? What a question. Why do you want to try Rust? Why do you want to do something you've never done before? Like, why not? I don't have any like goals or expectations or needs for it. Alright guys, I'm gonna wrap up the stream here. So, if you have any questions or anything, let me know. I'll probably be putting these up somewhere, these streams. I don't know where exactly. I used to make them available to like $3 patrons or $5 patrons actually. But I don't know. I don't know if I'll keep doing that. If you guys want to support Hazel and also get access to it, then patreon.com/thecherno is where you can go. And Wednesday, if you go to twitch.tv/thecherno, I'm sorry, I'm so tired, /thecherno/schedule, then you will, you can see when I'm streaming next, which will be like in a couple days, but it'll be in the morning. This is the evening for me. So, different kind of time zone. And then I'll be streaming the same time next week as well. So I've got like an evening stream and a morning stream is my plan. Unless something comes up. Yeah. Any questions? Any final thoughts? If not, then I will see you guys probably on Wednesday for those of you. Oh, excuse me. Those of you who join in. All right. I'm gonna go and like have a break. So I'll see you guys next time. Thanks for watching. Love you all. Bye.